Hello everyone, welcome back to our channel Problematical. Today we'll be discussing the solved examples from chapter 12th Maths NCERT class 11th. First question is, in figure 12.3, if P is equals to 2, 4 and 5, find the coordinates of F. Now coordinates of point P is known. We know that in this adjacent figure 12.3, if P coordinates are 2, 4 and 5, then this x value will be equal to 2, y will be equal to 4, and z will be equal to 5. If this point P is projected over here, you have to find the coordinates of F. So PF is here perpendicular to your xz plane. PF is a line segment perpendicular to xz plane. So F can be considered as foot of the perpendicular from point P on xz plane, another way of saying it. And this point F, here this line nullifies each other. This line is parallel to y-axis. Your FP is parallel to y-axis. So your y coordinate is being reduced to 0. Also in xz plane, your y coordinate is 0. So the coordinates of point F will be 2, 0, 5. So x and z coordinates will remain as it is, only y coordinate will be 0. Find the octant in which the points -3, 1, 2 and -3, 1, -2 lie. So we know that in a three-dimensional geometry, a three-dimensional coordinate system, there are 8 octants, 8 regions. Here, your x coordinate in the first point E, -3, 1 and 2, your x coordinate is negative, y coordinate is positive, and z coordinate is positive. Now, this is the situation of your second quadrant, the second octant. In second octant, your x is negative and y and z are positive. So this is your point A lies in the second octant. Next point B, -3, 1, -2. Here your x is negative, y is positive, and z is negative. This happens in your sixth octant. Next, find the distance between points P and Q. The coordinates of points P and Q are given. So we will apply the distance formula over here. PQ is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Here, these are your x1, y1, z1, and this is x2, y2, z2. This will be equal to, in place of x2, we'll write -4, x1 will be 1, -4, -1 whole square. Similarly, 1 minus of -3 whole square plus 2 minus 4 whole square is equals to -5 square, 25, plus 1 plus 3, 4, 4 square, 16, plus 2 minus 4 minus 2, 2 square is 4. 16 plus 4, 20, 20 plus 25 is root 45. 45 is 9 into 5. So this is 3 root 5 units. Next, show that points P, Q, and R are collinear. Now, collinearity can be shown either through section formula, or through the distance, calculating distances. So we'll calculate distances. We'll calculate the value of PQ, QR, and PR. So again, by using the distance formula, x2 minus x1, that means 1 minus of minus 2 whole square plus 2 minus 3 whole square plus 3 minus 5 whole square. This is equals to root of 1 plus 2, 3, 3 square 9 plus 2 minus 3 minus 1 square 1 plus 3 minus 5 whole square, which is 2 square 4. This is equals to root 14. QR is equals to root of 7 minus 1 whole square plus 0 minus 2 whole square plus minus 1 minus 3 whole square. This is equals to 7 minus 1, 6 square 36 plus 2 square 4 plus 4 square 16. This is equals to 40 and 16, 56. PR would be 7 minus 2 whole square plus 0 minus 3 whole square plus minus 1 minus 5 whole square. This is equals to 7 minus of minus 2, which is 7 plus 2, 9. 9 square 81 plus 0 minus 3, 3 square 9. This is 90 plus minus 1, 36. 90 plus 36, root of 126. Now, by these values, we cannot come to any conclusion. We cannot know which values are which. So let's try and convert it into much more reduced form. So 56, 4 into 14. So this is 4 into 14, which can be written as 2 root 14. Similarly, root 26 can be written as root of 3 into 14, 3 into 3 into 14, or 9 into 14, which will be 3 root 14. Now, by observation, if we add PQ with QR, this is root 14 plus 2 root 14. We'll end up with 3 root 14, and this value is equals to PR. So we can say that PQ plus QR is equals to PR, which means if this is your PQ and this is your QR, then PQ plus QR will give you PR. This is only possible if all 3 points P, PQ and R, they lie on the same line. So the interpretation of this is, therefore, P, Q, and R are collinear. Next, are the points A, B, and C the vertices of a right-angled triangle? So, in a right-angled triangle, if we draw a right-angled triangle, we know that one side square plus second side square, where the angle 90 degree lies, will be equal to the hypotenuse square. If this condition follows, only then we can call such a triangle as a right-angled triangle. Let's calculate these 3 distances, AB, BC, and AC. AP will be equal to root of 10 minus 3 whole square plus 20 minus 6 whole square plus 30 minus 9 whole square. This is equals to root of 7 square 49 plus 20 minus 6 14 square 196 plus 30 minus 9 whole square, which is 21 441 21 square. This will be equivalent to root of 686. Okay, this is your AB value. Now you need the squares of the distances. So you can calculate AB square instead of AB. The root will be nullified and you'll end up with 686. Let's calculate BC square. So BC square will be, the root will be nullified on the right hand side itself. 25 minus 10 whole square plus minus 41 minus 20 whole square plus 5 minus 30 whole square. 25 minus 10 is 15. 15 square is 225. Minus 41 minus 20 is minus 60 plus 61 square plus minus 25, which is 625. Now this you can calculate separately. We'll end up with 3721 plus 625, which is equals to 4571 in total. Now AC square. AC square will be equal to C, which is 25 minus 3 whole square plus minus 41 minus 6 whole square plus 5 minus 9 whole square. This is equals to 25 minus 3 will be 22 whole square. 22 is 484 plus minus 47 whole square, which is 2209 plus 4 square 16. This will give you 2709 AC square. Now this is the biggest value, BC square. So ideally speaking, your AC square plus AB square, this should be equal to BC square, the highest value. Only then we can call this as a right angle triangle. Let's calculate this addition value. 2709 plus 686. If you add these, you get 5933. Now, by observation, this value is not equal to 474571, which means your AC square plus AB square is not equals to BC square. So, your conclusion would be A, B, and C are not the vertices of a right angled triangle. Next. So, find the equation of set of points P such that PA square plus PB square is equals to 2 times K square. Now, we'll assume the coordinates of P are X, Y, and Z, and it's given that the coordinates of points A is 3, 4, 5, and B would be -1, 3, -7. So you'll apply these values. PA whole square. Now PA value is in terms of root. So root and square will nullify each other. You'll be left with x minus 3 whole square plus y minus 4 whole square plus z minus 5 whole square. Similarly, for PP whole square, your root and square will nullify each other, and it will be x minus of -1, x plus 1 whole square plus y minus 3 whole square plus z plus 7 whole square will give you 2k square. So Solving this, you have x square minus 6x plus 9 plus y square minus 8y plus 16 plus z square minus 10z plus 25 plus x square plus 2x plus 1 plus y square minus 6y plus 9 plus z square plus 14z plus 49 is equals to 2k square. Now, you had x square, y square, z square, and x square, y square, z square will form 2x square plus 2y square plus 2z square. Next, with these values, minus 6x minus 8y minus 6x minus 8y minus 10z 2x 6 minus 6y 14z. So this will be minus 6x plus 2x minus 4x minus 8y minus 6y minus 14y and z, which is minus 10z plus 14z will give you plus 4z. And now whole squares, which will be circles. So yeah, the constant values 9, 16, 25, 1, 9, 49. So 9 plus 16, 25, 25 plus 25, 50, 50 plus 1, 51 plus 9, 60, 60 plus 49, 109. So plus 109 is equals to 2k square. Here, you can take 2 common from all these values and you can take 109 on the right hand side. So we'll be left with 2 times x square plus y square plus z square minus 2x minus 2y minus, sorry, not 2y, 7y plus 2z is equals to 2k square minus 109. Now here, if you want, you can take this 2 on the right hand side. So you have x square plus y square plus z square minus 2x minus 7y plus 2z is equals to 2k square minus 109 whole upon 2. Next. Find the coordinates of the point which divides line segment joining points, the given 2 points A and B, say, in the ratio 2:3, first internally and then externally. So let's consider 2 points A and B whose values are given to you and coordinates of the point. Now we are considering a point P which internally divides AB in the ratio which is given 2:3. So let's just name these values over here. This ratio is given 2:3. P coordinate is not given. We'll consider it as x, y, z. A will be 1 minus 2, 3, and B is equals to 3, 4, minus 5. Observe, the sequence should always be maintained. The ratio given is 2:3, and the points are A and B. So with A, the distance should be 2, and with B, the distance should be 3 of the given point, either internally or externally. Either way, this point is A, and this is distance with A, and this point is B, and this is distance with B. Now, with this information, let's apply section formula and get the value of coordinates, get the coordinates of point P. By internal section formula, we have point P, x comma y comma z is equivalent to 2 into 3 plus 3 into 1 upon 2 plus 3. Y coordinate would be 2 into 4 plus 3 into minus 2 upon 2 plus 3, and Z coordinate will be 2 into minus 5 plus 3 into 3 upon 2 plus 3. This will be 6 plus 3, 9 divided by 5. 8 minus 6 will be 2 upon 5. Then, one second. Yeah. Minus 10 plus 9 divided by 5, which is minus 1 upon 5. So this would be the coordinates of point P. Next, we'll consider another line segment. Now you are supposed to divide this AB externally. So the point, let's call it Q, lies outside AB. Now Q is at a distance of 2 units from A and 3 units from B. So it is closer to A and further away from B. So we'll write point A over here and point B over here. So it is Q is closer with A, closer from A. This distance is 2 units and this complete distance is 3 units. This is what is given. So you can consider this as 2 units and the whole thing as 3 units. Also, coordinates of A is given 1, minus 2, 3. B is given 3, 4, minus 5. And Q point will be assumed as X, Y, Z. Let's call it X dash, Y dash, and Z dash. So, by external section formula, the Q point X dash, Y dash, Z dash will be equivalent to 2 into 1, 2 into 3 minus 3 into 1 upon 2 minus 3. So distance 2 is from with A. So 2 into the opposite coordinate 3 minus 3 into opposite coordinate 1 upon difference of the 2 minus 3. Now, similarly, you have 2 into 4 minus 3 into minus 2 whole upon 2 minus 3 and 2 into minus 5 minus 3 into 3 upon 2 minus 3. So this will give you 2 into 3, 6. 6. 1 second. Yeah. 2 into 3, 6. 6 minus 3 is 3 upon 2 minus 3 is minus 1. So it will give you minus 3. 8 plus 6 upon minus 1, which is again minus 14, minus 10, minus 9, minus 19 upon minus 1 is plus 19. So these are the coordinates of your point Q. Next, using section formula, prove that these 3 points, given points, are collinear. Now it's given in the question that you have to use section formula. That means no other, you cannot use by default, you cannot use the distance formula method. Let us name these points as A, B, and C. Let A be minus 4, 6, 10, B 2, 4, 6, and C 14, 0, minus 2 be the given points. So now if you are using distance formula, what you should do is you should take any 2 points over here. In place of A, B, and C, we'll take any 2 points. Let us consider A and B. So your A point, according to your consideration, is -4, 6, 10. And your B point is 2, 4, and 6. And you'll consider a point P with values x, y, z coordinates, which is dividing AB in the ratio k:1. Now you'll apply section formula over here. This is your next step, to apply section formula over here and get the coordinates of point P. So by section formula, you have point P, x, y, z will be equivalent to k into 2, 2k, internal section formula plus -4 upon k plus 1, 4k plus 6 upon k plus 1, 6k plus 10 upon k plus 1. Now here, 2k minus 4 upon k plus 1, sorry, now let us examine whether we have the value of k for which point P coincides with C or not. So we'll do one thing. Instead of x, y, z, we'll let any point, any one coordinate from P be equivalent to the coordinate of C. Now the first coordinate of C is 14. So let x is equals to 14. Let x is equals to 14. We've considered 14 because 14 is the x coordinate, which is the x coordinate of C. Okay. So we've considered one of the coordinate of point P as equivalent to C. If you do that, then you can equate this x with this. Your 14 will be equal to 2k minus 4 upon k plus 1. Your 14 into k plus 1 is equals to 2k minus, you can take 2 common. This 2 will be cancelled with 7. So you have 7k plus 7 is equals to k plus k minus 2. And here 7k minus 7 is 6k is equals to minus 14. So k is equals to minus 14 upon 6. Hold on, give me a second. Yeah, so we have 7k plus 1, this will be 9. Okay, so 7k plus 7 is equals to k minus 2. 7 goes over here, you have minus 9. And 7k over here, you have 6. So k is equals to minus 9 by 6, which is equals to minus 3 by 2. Okay, so now that you have the value of k, what you should do is, you should place the value of k over here in these coordinates, here and here, and we'll see whether we get the coordinates of C or not. Therefore, 4k plus 6 upon k plus 1 will be equal to 4 into minus 3 by 2 plus 6 upon minus 3 by 2 plus 1. This is equals to minus 6 plus 6 upon 1 minus 3 by 2, which is minus 1 by 2. So numerator will be cancelled and you'll be left with 0. Also, in the second value, you have 6k plus 10 upon k plus 1 is equals to 6 into minus 3 by 2 plus 1 plus 10 upon, this is 3 minus 3 by 2 plus 1. Minus 9 plus 10 is 1 upon, this is minus 1 by 2. This in the numerator will give you minus 2. So by placing the value of k as minus 3 by 2, we get the coordinates of p equivalent to coordinates of c. In short, p and c coincides with each other, then your k is equals to minus 3 by 2. The fact that k is negative states that point P is not dividing AB internally, but point P is dividing AB externally in the ratio 3:2. The numerator is with respect to A, so P is closer to B because denominator 2 is smaller. So you can easily say that point C is a point which divides AB externally in the ratio 3:2. Hence, ABC will be collinear. Since a point is dividing the other point in a particular ratio internally or externally, we can say that all 3 points should lie on the same line. You can write these as since point P is equivalent to point C for k is equals to minus 3 by 2. Therefore, point C coincides point C divides the line segment AB externally because of the negative sign in the ratio 3:2. So C is dividing AB in the ratio 3:2, that is C is at a distance of 3 units, 3x from A and 2x from B. Next. Find the coordinates of the centroid of a triangle whose vertices are x1, y1, z1, x2, y2, z2, and x3, y3, z3. Now, in your text, the formula for this centroid of a triangle is not directly given, but it is given in this solved example, which later on will be used as a formula in your exercise. So what you're supposed to do is you'll first consider a triangle. Let triangle ABC or let ABC be the given triangle. Let ABC be a triangle, be the triangle which we are considering. So now we can draw this triangle and we'll consider the vertices ABC, but the values of ABC, the coordinates of ABC are given in the question. So A is x1, y1, z1, B is x2, y2, z2, and C is x3, y3, z3. Now, what is a centroid? A centroid is a point where your midpoints, where your medians meet. So if you draw a line segment ED over here, D is a point over here. if you draw another line segment, this one, and a third line segment here, this one. So let this be CE and PF. Then here we have medians. These medians are meeting each other at a point, and this point is said to be centroid. Let this point be G, centroid. Now, if this is a centroid, then we know that another property of centroid is your centroid divides your line or median AD in the ratio of 2:1. That means this is another property of centroid, is that it divides line AD or median AD. AD is the median because it's dividing BC into two equal parts. So your point G will divide AD in the ratio 2:1. We know that a centroid divides the median in the ratio 2:1. Now your job is to get the coordinates of point G. Coordinates of point G, let it be x, y, z. You can get these coordinates if you have the coordinates of D, because in AD, then you can apply the section formula and get the coordinates of G. Right now, you have A is given, you have 2:1, but you do not have D. Now, D is the midpoint of BC. So, D is the midpoint of BC. If D is the midpoint of BC, then coordinates of point D will be equal to x2 plus x3 divided by 2, y2 plus y3 divided by 2, z2 plus z3 divided by 2. Now, this is your point A, this is your point D. Here your coordinates is x1, y1, z1. Here your coordinates are, which are given over here. And you have to find the coordinates of G, and it is dividing it in the ratio 2:1. So let's calculate for G. G will be equivalent to x1 plus, here, let it be capital X, capital Y, capital Z. So this is your capital X, this is your capital Y, and this is your capital Z. G will be 2 into this one, so 2 into x2 plus 2 into x3 minus, so it is 2 into this value, capital X, which is x2 plus x3 divided by 2 plus 1 into x1 whole upon 2 plus 1. Next, we have 2 into y2 plus y3 divided by 2 plus y1 whole upon 3. These will get cancelled. 2 into z2 plus z3 divided by 2 plus z1 whole upon 3. You'll be left with G is equals to x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3 Z1 plus Z2 plus Z3 divided by 3. Next. Find the ratio in which your line segment joining the given points is divided by the xy plane. So you have a line segment, ratio in which the line segment joining these points. So let these points be A, 4, 8, 10, and this point be B, 6, 10, minus 8. You have to find the ratio of the line segment, ratio in which the line segment joining these points, ratio in which this line segment is divided by the YZ plane. So let this point be P. You are asked that a plane is cutting a line. That means this point P is lying both on the line as well as the plane. You can also visualize this by first drawing the plane. Then drawing the line. This is a line that is piercing through the plane at a point P. So this point P is the only point of intersection between the line segment AB and your plane YZ. Now any point lying on this plane will have its x coordinate 0. So point P can be written as 0, y, z. Its coordinates can be written in this fashion. You have to find the ratio in which this line segment is divided. So let us consider this ratio. That means AP upon PB is to be calculated. Let this ratio be k:1. So your job is to calculate k:1. Your job is to calculate k:1. So now you can directly apply the section formula over here. AK coordinates is given 4, 8, 10. P is 6, 10, minus 8. You can calculate this by coordinates of point P, 0, y, z will be equivalent to k into 6, 6k plus 4 upon, you have k plus 1, comma, 8 plus 10k upon k plus 1 plus 10 minus 8k upon k plus 1. You need the value of k. You need not know the value of y and z. So you equate 0 with this. 0 is equals to 6k plus 4 upon k plus 1. So here k plus 1 goes on the left. 0 is equals to 6k plus 4. Where 6k is equals to minus 4. K is equals to minus 2 upon 3. Which means that since k is negative, you can say that your point P divides AB externally in the ratio 2:3. Okay. So that concludes this exercise. Thank you.